This is 6 and 7 on homework 34, I believe. 34, is it? 37, homework 37, okay? Okay, so the proof starts off with the circle at the center O, and NR is parallel to PS. So we want to extend that a little bit, extend those parallel lines. So do that to see them. And we really have two transversals here. We have this transversal and we have this transversal. So we have the 8 pairs of angles here, and we have the 8 angles here, not pairs, but 8 angles. Okay, so we have to see those. Now, if these two lines are parallel, these angles are either supplementary or congruent. And what we have to prove is triangle POS, which is this big triangle here, is isosceles. So if we can prove like this angle congruent to this angle, or this side congruent to this side, we got it. So let's keep going here. Let's extend those parallel lines so we can at least see the angles. Okay, so let's take a look at the proof for this problem. And it starts off with something like this, where we draw 2 columns here. Make this a little shorter so I have room for the other one. So we have a statement here and a reason here. And number 1 is circle at the center O. Okay? So, excuse me, that's given. And then the second thing would be that NR is parallel to PS. And that's given. So I would say first that if NR is parallel to PS, okay, then I would say that this angle is congruent to this angle. Now, if the circle is at the center, I would also say that this segment is congruent to this segment. Okay? And then also we can say that this angle is congruent to this angle because of the parallel lines. Now, it gets a little tricky after that, but we have to get this angle congruent to this angle. Let's do it. Okay, we're going to do it with transitive property. So the third thing I would say about this proof is that ON is congruent to OR. And that is because radii are congruent. Now, I would say that triangle NOR is isosceles. And you can say that's isosceles because 2 sides congruent. All right, we have the 2 sides congruent there. Now, I would say that the angles are also congruent, okay, because it's isosceles. So angle ORN is congruent to angle ONR. Right, that's these two. And that's if the 2 sides of the isosceles triangle are congruent, then the 2 angles, the base angles. Then what I would do is say, all right, well, I've got these 2 angles congruent. Now let's get angle ONR congruent to OPS. So angle ONR is congruent to angle OPS. And that is, if the lines are parallel like they are up here, then the corresponding angles are congruent. Now, also, it's the same reason that these two angles, ORN and OSP. Angle ORN is congruent to angle OSP. And that's the same as 6. All right, well, we have these two angles. We have these two angles congruent. We have these two angles congruent. We also have these two. So that makes these two bitransitive property. So angle OSP congruent to angle OPS bitransitive. So we're done. That triangle POS, is isosceles. And that is because if base angles congruent, then the triangle is isosceles. Now that was a long proof, that was 6 minutes, so let's get through the other one here. And the other proof says given G is the midpoint, okay, of FC, all right, that makes these two segments congruent. And FC bisects BE, so that makes these two segments congruent. All right? Now we want to prove here that FE, which is right here, is parallel to BC, which is right here. Okay? So if we could get, say, angle 3 congruent to angle 4, we could do it. And it just so happens in this proof that I can see these two triangles are congruent by side angle side. The angle in the side angle side is this vertical angle right here. And if the two triangles are congruent, 3 and 4 are congruent by CPCTC. And you can, I hope, see that angle 3 and angle 4 here. Here's angle 4, and here's angle 3. Those are alternate interior angles. All right, so let's set out to prove this sucker. Okay, so we're going to do it with a 2-column proof. And then the first thing we're going to do is say that G is the midpoint of FC. G is midpoint of FC. So that's given. All right, and that tells us, all right, that FG is the same as CG. Because midpoints create congruent segs. All right? And the second, or the third step would be given that FC bisects BE. And that's given. And now from that given, I can say that since FC, now here's FC, pay attention, bisects BE, all right, that would say that GE is the same as BG. And that is bisect creates congruent segs. All right, much like midpoints create congruent segs. All right, so now we got to get the vertical angles in there. Angle FGE is congruent to angle BGC. I guess we can say CGB. All right, and that's vertical angles. Angles, congruent. All right, and then 6, triangle FGE is congruent to triangle CGB by side angle side. And the first side is 2, and the angle is 5, and this third side is 4. All right, from bisect and midpoint, the two sides. All right, so 2 more steps. Now we can say angle 3 is congruent to angle 4. Angle 3 is congruent to angle 4 by CPCTC. And the last step is that FE and BC are parallel. FE parallel BC. And that is because if alternate interior angles congruent, then parallel. Then we have parallel lines. Okay? All right, that's not easy. It's not easy being cheesy, but that's how we do it. Okay, on the first proof, just to go back, we have a circle, okay, and then we have radii from that circle, and then we have this triangle as isosceles, and then we have these 2 angles congruent because of the isosceles, and then these 2 lines here are parallel. That's that next given. That makes this angle congruent to this angle because if the lines are parallel, the corresponding angles are congruent. Then we have these 2 angles congruent by the same reason. And by transitive property, we get these 2 angles congruent because this and this are equal, this and this are equal, and these 2 are equal. That's the transitive property. And then we have base angles congruent, giving this triangle the property of isosceles. All right, number 7. We have midpoint to make congruent segments. We have bisect. FC is the bisector of BE, making 2 congruent segments. And then we have vertical angles. So the 2 triangles, this blue one and the green one, were equal. And 3 and 4 were congruent by CPCTC. And 3 and 4 here were alternate interior angles to make BC parallel to FE. And that's what we had to prove. Okay? Not easy proofs, but not impossible. Okay? We're not building a ship to Mars. We're doing high school geometry, which is something you can do with practice. Have a good day.